Hey, welcome everyone. Today we're going to discuss Pythagorean triplet question 16 of arrays from Geek for Geeks. Must do coding question for interview. So just have a quick look at the question and after that we will be discussing the approach to the question. Now, what does this question say? Is we have to find a triplet where Pythagorean theorem says a square plus b square should be equal to c square, right? So this is the formula for Pythagorean triplet. We have to find one variable where if we add two values, then we should have the c value which should be in the array. Suppose for this array 3 and 4 are the answers. Okay, so 3 square is 9 and 4 square is 16. We get 25 now total. Okay, and 25 square is c here, right? C square equal to 25. So now c will be equal to 5 in this case. As you can see, c equal to 5 is inside the array. So how can we know that it is inside array? By using the coding. For that we are going to use an hash map. Okay, hash map is useful here. So by using hash map, we're going to take every possible combination and we do the square and check if the value is there inside the array or not. So now taking a hash map, we initialize with 0 values. And here you can see in the hash map, we have taken total 7 values. Why we have taken 7 values is because here, if you see, we have 5 values inside the array, but we have taken like 7 values. Why is it? Because we are going to check every possible combination using the maximum value from the array. So max value from the array, which is 6 here, okay, which is 6 here. So we will be checking every possible combination up till 6, from 0 to 6, like 0, 6, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5. Okay, and we are only checking these values because when we have initialized the value hash map, and then we're going to loop through the array and see if that is inside the hash map or not. If it is inside the hash map, we update the value inside this. If you see carefully here, 0 and 1 key, we don't have that in array. We only have from 2 to 6, right? So 0, 1, that will be 0 only. So these other values from this side to this, everything will be updated by 1, and everything is updated by 1 here. Okay, why we have done, we will know this in next step. Okay, so in next step we will again loop through. Okay, this will be the left key will be treated as I and right key will be treated as j. So I j are two loops. Okay, two for loops here, and we check from first for loop taking I. Okay, I here, and we have to iterate all the array here. Okay, we have to iterate all the array for I in range. Okay, this is the range for I and this is the range for j, which is 1 to n and 1 to n. For in this, we are iterating to all the possible combinations. Okay, first we'll be starting from 1 0 1 1 1 2 and so on. So while doing that, we have to check if that value is inside the hash map or not. So this 0 here, this 0 represents that the value is not present in the hash map. If the value is not present in the hash map, then it is also not present in the array, right? So we check in the hash map in the I loop here if that value present or not. Check inside hash map if the I is present or not inside the hash map value. Check hash. So after checking if the value is present, we continue to the next statement. The value is not present, we use continue statement here. If we are using continuous statement, then it will directly update the value of I. So benefit of updating the value of I here is if 0 is not there, then it will update with the 1. So 1 is also 0, which is also not present. Then again it will continue, it will update directly. So by doing this, we don't have to go to the next step, and it saves it saves the time of the program. So when we reach the second part, now the value is 1 here because we have updated the value and this value is present inside the loop. So now it will go to the second for loop for j in range I 1 to n, right? Here also we have to check again. Here also there are two conditions. We have to check if I equal to j. If I equal to j, then that means there is only one element here. So in that case also we continue because we need two different values here, not the same value. Okay, two different values. Or other condition could be that we have to, if the j value is not inside the, if not present inside the hash map, like we have checked for I, the value is not there, 0 or 1, right? Similarly, for j value also, the element may not be present in hash map, right? For that also, we just use the continue statement here. Okay, we use continue statement here. Continue. So this is the one condition here, that we check if the j value is present and if the j value is equal to I value or not. So if it is equal, we continue and it will directly update the value of j. So it will move to the next combination. In this example, just purely looking at the values here, we will start from second here. This is the first value that has present in the hash map. So 20. So I have written some values here, right? We haven't started from 20 because I only wrote the values which we are taking into consideration, like 2 and 0, like 0 0. See, if you see inside, the 0 value has 0, right? 0 key has 0 value. So this element is not present, so we didn't consider. Similarly for 2 1 also not present. We didn't consider because 1 key has 0 value. And again similarly for 2 so here in this case I equal to j, right? 2 is equal to 2 here, right? So I told here if it is equal to, we continue and update the value of j, right? There can only be two different values, right? There can't be just one value for everything. So this we ignore and we just update the value. So we haven't considered 2 also. Similarly for other values, for 3 and 4, starting from 3 and 4, we haven't considered those values. Okay, we have only considered those combinations which are considering inside the loop. So starting from 2 3 2 4, if you just whole square, we get 4 and a 9 here, right? Similarly, if you take a look here and if you keep on adding, some of them you may get perfect square, some of them you may not get perfect squares, right? For 2 3 we got 13, and 13 is not a perfect square, right? 13 is not a perfect square. So if the value is not perfect square, other condition will be perfect square. We have to check if the value is a perfect square or not. So we have to check the value is perfect square or not here. If it is not perfect square, then we again continue. If perfect square, then we move to the next step. If value is not, right, it is not a perfect square, then we continue means we just update the value, because we don't want value which is not a perfect square. Okay, first we have to know that it is a perfect square. After knowing it is a perfect square, then we check inside the hash map if that value is present or not, right? The element should be a perfect square. If it is a perfect, so then may move on to the next step. Then we check if hash map has the value or not. Inside the hash map, we check hash and we put the value here directly. So what it is doing is, it is checking if the key for the value is present inside the hash map or not. Okay, now we found the value, right? If it is present, then only that value is available inside the array. So if it is present, in case of 3 and 4, the value will be present, right? It present. So then we return the value. If it is present, we return the value. Okay, we return true here. There is other condition before the hash map value. Before checking the hash map value, it is there or not. There is other condition. So the other condition is, if the value, right, after taking the perfect square, right, we are checking here perfect square, right? So when we are checking perfect square, we also have to check if the value is smaller than the maximum value that we are taking. The maximum value is 6 inside this array. So there can be no other value which could be greater than 6. If we are doing the square, then we are seeing that square is greater than the value, max value inside the array. Then that means obviously that element is not present, right? So in that case also, we continue. Continue means we update the next value. We ignore the current index value and we update the next index. Okay, we use continue here. We use continue if it is greater. If it is greater, we use continue. If it is smaller, we don't do anything, right? If it is smaller, that is good. But if it is greater here, just in case if it is greater, then we have to use continue. Continuous, we have to update the index value here. One by one, the value will be updated. And so after finding that value, we return true. Like we are checking one by one combinations, right? 3 4, we found that it is a perfect square and we got the value 5 here. Okay, value 5 is smaller than a max value 6, so fine, it's fine. We need which is smaller than 6. Okay, and now we have to check if it is present inside the hash map value. So 5 is present inside the hash map value here. Okay, good. Now 5 is also present and it is also present in array and is also smaller than the maximum value. That means we found the value which is 3 and 4. These two are the values which are there, 3, 4 and 5. So these three are the triplets in this case. So we found a triplet now. If we found the triplet, we are returning here. Okay, we are returning. So this is the logic behind the question. Now let's go to the coding part and it will be more clear what is happening. Welcome to Geek for Geeks, and this is the coding part of the question. And you may also find this same code in the Geek for Geeks website. And the logic we have discussed here is we are taking the maximum value of the array, right? Take the maximum value, and then we are initializing it as a hash map of maximum number of elements, which is 6 in this example that we had to see. We got the 6 value. This is the example, and 6 is the max here, right? If we just use maximum and 6, then we get up to 0 to 5 index only, but we need 0 to 6 index. That's why we have added +1 here. We get 0 to 6 index of hash map. Okay, now we are checking inside the array if that element is present or not. Okay, if the element is present, we are updating its value by 1. If it is not, we are not going to update. It will not update. Okay, like 3 2 4, right? We are starting from array I 0 1 2 3 4 5. You can see only 5 values are there, right? We'll check for 2, then it will check 3 4 6 5 similarly. Then it updates its value to 1 by default. Other remaining values will be 0 by default because we have initialized it already. So other remaining values will be default by 0. And here we're using other two loops again. The first loop is the first combination, like 2 1 2 2 2 3. First key value which can be 2 3 4 6 5, which are present in array. But if it is not present inside the hash map, okay, we have updated values here 1 which are present. But if this one number, right, the example like 1, right, it is starting from 1. Now hash 1. Now we check inside the hash 1. So hash 1 equal to 0 because 1 is not in array. So that value hasn't been updated. By default it is 0. So if the value of the key 1 is 0, then that means that it is not present inside the array also. So in that case, we update the index value by using continuous statement. We don't go below. After updating, it will start from 2. Now it checks again inside this if 2 is available or not inside the hash map. Now 2 is present inside the hash map because it is inside the array also. So 2 value, right? Value of 2 key is 1 here. That means it is present. So this statement will be ignored because hash map value is 1 here, right? It will only execute if it is 0. If it is 1, it ignores this statement. It will move to the next loop. And here, for all the possible combinations of 2 will be executed from 2 1 2 2 2 3 2 4 2 5 2 6. Similarly for 3 4 and remaining other elements. I told you that I cannot be equal to j. Like suppose 2 equals to 2. It cannot be. There should be unique values. There cannot be same value. If it's the same value, then it is not a Pythagorean triplet. So in that case, we continue, right? And we also check if the hash value of j is present or not. If it is equal to 0, then that means it is not present in array also. So we just use continuous statement here. So next what we are doing, we are taking the square root, right? After doing the square root, we are rounding it to the integer value. Okay. Now if it is a fraction value like 3.101, then int will convert into 3 only, not 3.1, right? But we need perfect squares. For perfect square, we are using value into value and I equal I into I plus j into j. If it is a perfect square, then we get the value perfectly, right? In this case, I told 3.1 is a value here. So after using int, we got 3, right? 3 into 3, we get 9. But again, if you square here, we will get some other value like 3.1, right? We get 3.1 and 3.1 something. So it will be in fraction in this case if it is not a perfect square. Assume that it is a perfect square root. This is 3 and this is 4. We got 25. Okay. Value is 5 here. 5 into 5 is 25. And here 3 into 3 9, 4 into 4 16. Total value is 25. 25 is not equal to 25, which is false because those values are equal. So that means it is a perfect square. Then we ignore the statement. Now we check the value 5 is greater than maximum value. If it is a maximum, we use continue. By continue, we just update the index value of j. Okay, but 5 is not maximum. 5 is not greater than maximum. Maximum value is 6 in the first example here. So it will ignore this statement, and next statement will check that 5 value is present inside the hash map or not. After checking the hash map, the 5 is present, right? So in hash map, 5 value, 5 keys updated with one value. So if it is updated with one value, then it means it is also present in the array here. So yes, the hash value is present, then we return true. After checking all these conditions, still we are not able to find the value, then that means the value is not present inside the array, then we return false. So this is the logic behind this question. If you understand, please give us a like, and we'll be doing more videos like this in the future. And don't forget to subscribe and share with your friends. Thank you, and we'll be meeting in the next question.